So here's the circuit that I wired up. This is my 7440. This is my 7447, which is a common anode driver. This is my 33 ohm, 330 ohm resistor pack. This is my common anode display. Looks very, very complicated, but as long as you follow your pin outs, hook them up. So basically, I just started going from here, and then I went A segments on this resistor, B, C, D, E, F, and G. And then when I came up here, it came up on my 7442, I just went A, B, C, D, E, F, G. So this is the output of my 7447, excuse me. This is on the other side of my resistor pack. Remember, this is a common collector. An open collector. So it cannot output a 1. But what it does, it just turns it off. So it's definitely acting like a switch, but it's switching the ground is what it's doing. Okay. So what we're going to do is we're going to look at the lab and see what's required. So right now it says what I'm going to do is open all the switches. It's not open all the switches. What we're going to do is we're putting in all highs. Now what I'm going to do is I'm going to show you. This thing is a 7-segment decoder driver, and what it'll do is let's see if it shows us the actual truth table on the data sheet. I didn't bring up that. I needed to bring that up and look at it. So here's the 7447. I got 7447. And let's see if it gives us the function table in this guy. Yes, it does. So as it says, if I put a BCD0 on the input, it's going to display this. If I put a BCD1, it's going to display a 1. If I put a BCD2, it's going to display a 2, 3, 4, 5, 6, 7, 8, 9. Now that's all of the BCD digits. But there's nothing in this circuit right here that does not prevent it from decoding anything above a 9. So what it does, if I put a 10 if I put a binary 10 on this, it gives me this strange thing right here, 11, 12, 13, 14, and 15. What it would do, it would just blank the display. So right now, that's what I have on the thing. I have a 15, and it blanks the display. So what we're going to do is we're going to go through all the combinations so you can see it, and we'll see it do this weird stuff when it gets above 10. So right now we're not doing ripple blanking, so I've got those switches turned off. By the way, I redid the digits just to make it easier for me. So what I've done is this is A, B, C, and D, or the data sheets calls it A0, A1, A2, A3. But the actual pin out that we're looking at on page 97 uses A, B, C, D as our binary inputs. Then what I'm doing is I'm using switch 4 as my light lamp test. I'm using switch 5 as my ripple blanking in, and then I'm using switch 4. Got that backwards. I'm using switch 4 as my ripple blanking in. I'm using switch 5 as my ripple blanking in. I'm using switch 6 as my blanking in. This would be 4. So right now we've got all ones on and it blank, but we'll just go ahead and show you what happens when I do lamp test. So lamp test is switch 4. So switch 4. So we're going to do a lamp test. It's low active, and notice it turns on all 7 of the segments. So this has priority over whatever number you have. The lamp test has priority over your data switches. So no matter what I put on my data switches, so now we have a 0. If I come up here and do a lamp test, it turns on all 8. So no matter what numbers I do. So here's all our combinations. We're not doing any lamp tests. We're not doing any ripple blanking. All we're going to do is go through all 16s of combinations on these 4 switches right here. So right now I have a 0. I have a 0, and my 7-segment display is displaying a 0. Here I have a 1. a binary 1 and it's displaying a 1. Here I have a binary 2 and it's displaying a 2. It's automatically taking a binary code and turning on the right segments. So it automatically turned on the WAD. It turned on the A segment, the B segment, turned the C segment off, turned the D segment on, turned the E segment on, turned the F segment on, and turned the G segment on because it saw a binary 2 come in on its input. This is a binary 3. The 7447 decoded that and turned on the right segments to display a 3. Oops. Here's a binary 4. Oops. Let me get my things back in order. So here's a binary 4. Oops. Map test, Rich. Here's a binary 4. Oops. Here's a binary 4, so it displays a 4. Here's a binary 5, it displayed a 5. Here's a binary 6, 0, 1, 1, 0, displays a 6. Here's a binary 7, it displayed a 7. Here's a binary 8, it displayed an 8. Here's a binary 9, 1, 0, 0, 1, displays a 9. Here's a binary 10, does that little weird thing it did before. Here's a binary 11, does that little weird thing that it showed us in the function table. Here's a binary 12. Here's a binary 13. Here's a binary 14. Here's a binary 15. It blanks the display. So that's all 16 combinations. It decodes true levels all the way from 0 up to 9. Anything above 9, it gives us a strange letter. So after a while, if you were dealing with this, we had a capture card. It was an error code capture card, and it did it in hexadecimal. But we used 7447s because that's what we had. And what it would do is it would send out numbers from 0 to 15, and of course that was okay. But when it did an A, which would be this guy right there, it displayed that code right there. And after a while, we learned the codes and we had no problems. So you might see this every once in a while doing this weird characters. We only ran into it once, and like I said, we were making a card that would capture an error code when a computer had a problem. So what we'll do is we understand what the lamp test does now, right? So the lamp test, whatever it does, it displays, no matter what's going on, it has priority. So even if I come up here and make it display a blank, the lamp test has priority. Okay. And the ripple blanking input, which is which is switch 6, it has priority over the lamp test. So this is what we're talking about blanking. So notice the faster I flip a switch, the more it looks like it's on all the time. So I can combine this with multiple displays, and what would it do? Then I could share the same data lines, the A, B, C, and D, and what I would do is I would blank one and the other. In fact, what I'm going to do is take the ripple blanking input and put it over to our clock, our digital clock, which right now is running at about 1 kilohertz right here. And to us, it looks like the display is on all the time, if I can keep it inside there. What was it doing? Oh, I'm sorry, we got it on 1 hertz. What I'm going to do is I'm going to speed it up so you can actually see it blinking now. So now you can see it blinking. And now it looks like to us it's on all the time. So right now that's 1 kilohertz. And to us it looks like it's on all the time because, why? Because our eyes are blending this together. So this guy here is actually flashing. And this is the way we can use those ripple blanking inputs to allow this to happen. So it says all switches, logic 1, is the display off? Why? Yes, it's off. Why is it off? Because it decodes a 15 as all of them being off, right? You understand? Close the ripple blanking. What does the display now? So we're going to do the ripple blanking, the switch 4, and notice what happens when I do switch 4. the display does what? The display blanks. Okay. Everybody okay there? Lamp test has priority over let's go back and put a number in first before it makes some sense. Let's move this back to because I'm going to close the ripple blanking switch 6. Switch 6 for me because I redid them to make them easy. So this is coming in on pin 4 of the 7447. I'm using switch 6. Now I've got it displaying a 0. Here's switch 6. And notice it blanks it. Now this is the one I was using a while ago, flashing it. So let's see which has priority. So this is switch 6. This is switch 4, which is what I'm using for lamp test. So the ripple blanking input has priority over the lamp test. So there's switch 6. Okay. So that's step number what? That's step number B. Open switch 1s, 2, 3, and 4. Alright? Y'all understand that? So what we're going to do is open. Now, on our diagram, an open means it's going to give us a high. So what we're doing on C, I'm going to turn all of them up, and of course the display blanks. Now why does it blank? Because if I look at the data sheet for the 7447, it says if I put a 15 on the input, it's going to do what? It's going to blank the display. So that's why that's occurring. I had to pause the video just for a minute because of my computer was running pretty slow. It's trying to do something. So open all switches is display off. Why? This is telling us to here. It says now we're going to open all the switches and close switch 4, 5, and 6. So we're going to open all in 7. So 4, 5, 6, and 7. This would display a 0. So I'm using the 3 switches there. If I need to rephrase this the way I've got it hooked up, because it's easier for me to do that. So it says I'm going to close 4, 5, 6, and 7. And of course it does what? It displays a 0, right? Because I'm putting in a 0 on the A, B, C, D inputs. Leave all the switches in their present position for close switch 3. So switch 3 is the lamp test. So lamp test, we've already looked at that. So lamp test comes on, it just always is going to display an 8, right? Leave all the switches in their present position, close switch 3, which is the lamp test, which is what I just did. Then it says with switch 3 still closed, which is putting a 0, open switch 5. Switch 5 is open. What did the display? Then it says with switch 3 closed, switch 2, which is our ripple blanking in. So we can see that. So it just blanks the display. So that's the 74LS47 lab. And like I said, it looks very impressive. But as long as you take your time, as long as you go ahead and put your numbers on your schematic and just do one wire at a time instead of trying to do a bunch of wires at the same time, then you should have no problem wiring this. Wired it up first time, no problem, without any problems, just by going ahead and putting the numbers on my sheet. So you can see I actually recorded the numbers, put the segments. There's one thing that's not on here, by the way, that I noticed real quick is they did not put a connection for VCC, and they did not put a connection for common. So you need to do this on your diagram, because what had happened several times, I should have remembered this, is students would wire the circuit up and it wouldn't work. And why wouldn't it work? Because they didn't have power. They didn't indicate where they needed power. So plus 5 volts VCC is pin 16, and then common is pin 8. And so I put it off to the right hand side because I had no problem. Got the pin outs across the top for my ABCD inputs. Now remember, on your data sheets, it's going to call them A0, A1, A2, and A3, which is your data lines. Lamp test, instead of using switch here. So what I wanted to use my data switches as 0, 1, 2, and 3, so they would stay in the video frame a lot easier. And then I just reassign those switches here. So I'm using switch 1 for A. I'm using switch 0 for A, switch 1 for B, switch 2 for C, switch 3 for D. Then I'm using switch 4 for my lamp test. I'm using switch 5 for my ripple blanking in, and then I'm using switch 1 for my blanking in or my ripple blanking out. So that concludes this section, which would be the 7447. Next, we'll be looking at the 74147, which is, so this is a decoder. It's taking a binary code, which is BCD, and it is converting it over to the code required to run a 7-segment display, common anode 7-segment display. If I wanted to use a common cathode 7-segment display, then I would use a 74 LS or 7448. So the 7448 is a common cathode driver. The 7447 is a common anode driver. And hopefully by now you'll understand what a common anode and common cathode 7-segment display is, because that would probably more than likely be on the